Hello guys, it's Ariel here, and this is video number 3 and 4. Today I'm going to use translation and some sound delaying, so I hope I'll end up with something like this. It's a simple with some rotating balls and image which is getting smaller, then it's getting bigger if he reaches the set size. Okay, let's start from scratch. Firstly, I'm going to import the OpenGL library because I work with Z-axis, so if there's any rotation, translation, and any animation, it's good to use OpenGL. Works faster and smoother. Let's set the window size. OpenGL, okay. Now let's go to the draw function. Set it in the black. Okay, now we want to place the image in the middle of the screen. Image which is in our sketch folder. I put it already. I put two files there. One is the image, another one is the sound. This is the image. I want to place it in the middle of the screen. I'm going to use translation to change my position on the screen. I'm using translation without push and pop matrix because I want everything to be as the starting point to be in the middle of the screen. That's why there's no push matrix. Let's start with the first ball. Oh, sorry. Let's put the image first. I'm going to use vertices and map them with my image. Okay. Now let's import the image. Let's call it atom load image. Okay. Let's set the texture mode. Texture. If we set the texture mode to normalize, we can use 0 and 1s as attributes. Okay, as my image coordinations, I will use the variable called image p, for example. Then I want at the beginning the size, for example, 200 pixels, because I want my image to be set it automatically, so I'm not going to put any numbers here, just using variable. So let's start in the corners. on the z-axis. Okay, now let's texture it. I'll texture it the same way I textured it in previous video. So I'm using the same coordinates. Sorry, not like this. No, I use normalized texture mode, so I will use the numbers. 0 is 1, and 0.1. This is the first corner, end of x and start y, end of x, end of y, start of x, end of y. Let's try if it works. Let's try. Okay, it's working. We have the image in the middle of the screen. Now I want this image to be going smaller, then going bigger. So how am I going to do this? I'll make another variable called difference, for example. And I will set it, for example, to 0.2. And to a smaller difference. At the beginning of the draw function, I'll just make subtraction. Difference. Then if statement to check if the image is enough small enough. So image smaller than, for example, 50, or image P bigger than 200. So how is it going to work? At the beginning, the size of the image is from minus 200 to 200, because specify it's minus. So that's 400 long. Then we're subtracting 0.2 each frame. If the image P is smaller than 50, the difference I'll just multiply it by -1. Then the difference will be 0.2. So there will be image P minus 0.2. So it will be addition, and Windows bigger. Let's check if it works. Yes. Go smaller. Then it will go bigger. Okay. Let's make balls. Typing balls. I'll use push matrix, pop matrix, to avoid dependencies during the creation of the balls, because I will specify the rotation attributes for each ball. Each ball will be different. So let's do this. music rotating to rotate the ball with the clockwise or anti-clockwise, depends what value you put here. Then I want this ball to rotate on the x-axis, so the ball will go through you and then it will hide behind the image. So this, for example, I will move it minus pi divided by 5 plus, for example, I'll use another variable to rotate it through. We can use it or can leave it. It's up to you. Maybe I'll leave it for now to explain better. Then, if I will use one variable for every ball, they will translate in the same moment, so they will meet together in the middle of the screen. But I want to avoid it, so I will rotate every ball at the same speed, but I will set the starting point at a different location. I'll show you. For example, pi over 7. Then I will place the first ball, so for example 200 above the image. Now how to create a ball with the area around it which is transparent. I will show you. We need two spheres and two fields. First field will be non-transparent and we create a small ball. Then inside this, but it will be bigger, so it will look like the smaller one is inside this, and this one will be transparent. Let's make it yellow. Non-transparent, higher value, lower transparency, and size of the sphere, for example, 5. Now the transparent sphere. So for example 40, and the size, for example 15. And now we have to create x value to rotate it. For example, each draw the x will be changed. For example, pi over 50, and we will value it by pi. So it goes up to the pi, then from 0 again. So let's create float x. Now let's try it. Okay, let's try it. Yes, you have a ball, but why it looks like this? Because there's a stroke, black stroke. That's why you don't see just the ball, you see the edges and everything. So let's call no stroke. Let's try now. Yes, you can see the ball now. Let's create more balls. So we do something similar. You just change some variables, rotation and position. So in this one, for example, we will set rotating position, starting rotating position, to be different than this one. We don't want this ball to meet this ball in the center, and for example we'll put it below the image. try to make some more. This one, so maybe pi over 5. Let's say 200. Here's okay. Another one. Let's say, for example, we will move it a little bit, pi over 2, and to be above. And let's create another one. For example, pi over 2. Okay, let's check if the position is not the same, because those two poles are the same position, so we will rotate one of them, another the anti-clockwise. Let's check those two. Let's say minus pi, because those two are similar. Okay, let's check this. As we have some balls rotating the image. Okay, so what is the effect for the light? In processing reference, you can find some light options. Let's try one of them. It's called spotlight, and what to put inside there. First, let's specify the color for our light. I want this light to be white, so 255, 255, 255. Then the position, so I want my spotlight to be in the middle and above everything. So let's say we'll divide it by 2, height divided by 2, and for example 900, just for fun you can play with. Let's specify the direction of the light. So I want my light to be like attached to the ceiling, and I want the beam to go to the floor. So 0 for the x, 0 for the y, and -1 for the z axis. Then specify the angle, let's say pi. Then the concentrate of the beam, let's say 50. Let's check this work. You can see that poles which are near to the middle, they are getting lighter, brighter, and the image goes brighter. Slowly it gets brighter. So we have simple effects. Then we're going to add some audio. Again, I will use the library from my school. So let's just copy the library. It's too long to rewrite it. Similar to the previous video, we will set everything. Okay. So we'll just copy the audio part with small difference. We'll make a small delay. So I've added audio data filtered buffer. Then is the audio part from the setup function. Let's see here. Okay, I'm giving the location of my file. I'm inserting the program. I'm setting the delay time for my delayed audio. Then I'm initiating and creating my audio data filtered out buffer. This is the one with the audio. This is the empty one for now. Then I'm assigning the part of the buffer which stores the samples from my sound but it's starting from the delay time, so I have to create a delay time. It's created here. You can set anything here, and it goes to the up to the end of the audio data. Then I make it smaller to don't sound creepy. Okay, and let's copy the audio function which plays the sound. And let's check if it works. The delay sound, delayed it. Let's check. Not delayed sound. As you can hear, the sound is different, is delayed by a part of the whole sound. So you hear only the loudest noise. There's the bell. Okay, that's it. Thanks for watching.